So with the questions here at the end, I think you need to assume that they're going to be tech-free. I probably should have it written on it. As soon as you see correct to a number of decimal places, you know all of a sudden it's calculator driven. But just quick reading, I reckon the next couple are tech-free. All right, circular match normally distributed. Sketch the probability density curve. So we're actually being told to do that. So because it's normally distributed, they're saying sketch a normal curve. And what are the key features? Mean is 12. So there's your mark there. All right, actually for 2 marks. Produced by, so we should probably, so just to make sure we get all the marks, on this, it's the probability of X, and that's X, okay? Now, for the rest of it, we're looking for 16% of mats produced by the machine have a diameter less than K. Find the value of K. So 16% is down here somewhere. So that's got to be area there of 0.16, all right? So that's 84%, the rest of it. So we're actually thinking, okay, it's really 1 standard deviation. So I'm really not too sure here. It'll be interesting to see. So we know that 1 standard deviation below gives me, there'll be 84% because don't forget that in there to there. So if I go 1 standard deviation up, 13.5, 1 standard deviation back, 10.5, in there is 34, in there is 34, which means from there to there is 84. So there's my 16% there at 10.5. So now I'm not too sure whether it is tech-free or not. But we'll use our case just to confirm. So I'm going to use the inverse norm, 0.16, mean 12, standard deviation of 1.5, and that gives me 10.5. So I actually suspect that all these will be tech-free, all right? But again, the benefit of a diagram certainly helps us sort that out. Let's have a look at number 2. The distribution of scores in a particular exam are again normally distributed. 30% of scores are less than 45, 30% of the scores are greater than 55. So if there's my curve, there's the mean, and I know that that value there, probably should make it a bit tighter. Maybe that value there, that's 0.3, and that value there is also 0.3. So because our normal distribution is symmetrical, I know that my mean has to be in the middle. So if that value there is 45 and that value there is 55, because either side is 0.3, my mean is going to be 45 plus 55 over 2, which is equal to 50, which hopefully kind of makes sense. Yeah? So there's the mean of my distribution. So further reading again, I changed my mind again. Now it's going to have to be tech active because what I need to know now is I know that the probability that X is less than 45, for example, is equal to 0.3. So I need to find an equivalent Z value. The probability that Z is less than what value is equal to 0.3, because then that'll give me Z equal to negative 0.5244. Now don't forget that this inverse norm, so I've gone inverse norm 0.301 for a Z distribution. Okay, so now I know that X minus mu on sigma is equal to z. Therefore, negative 0.5244 is equal to the x value, which was 45, minus the mean, which is 50, over the standard deviation. So sigma equals 45 minus 5 is 5 over negative 0.5244, which is equal to negative 9.5. Obviously, that should be a negative there for negative 5, because a negative standard deviation doesn't make sense. So I've got a mean of 50 and a standard deviation of 9.5. So maybe test mu is equal to 50, sigma equals 9.5. Make it really obvious so people don't have to go looking for it. All right, question 3. X is normally distributed random variable. This I like the look of as a tech-free. Okay, that mean of 72 and a standard deviation of 8. So again, step 1. I haven't even read the rest of the question, but I'm going to put down the information that I've got first. Mean of 72, standard deviation of 8. So 80, 88. What's that? 64, 56. Righto. Let the Z be the standard normal curve. Use the result that the probability Z is less than 1 is 0.84. So don't forget that that means the probability of being 1 standard deviation below. There's 0. That's Z equal to 1. And we're saying that all of that is 0.84. The probability that X is greater than 80. Well, 80 is 1 standard deviation below. And I guess to show that, let's get the corresponding Z value. So Z is equal to 80 X minus mu on sigma, which is equal to 8 on 8, which is equal to 1. And we know the probability that Z is less than 1 is equal to 0.84. So between 64 and 72, what does that mean? So between 64 and 72 is this section here. Yeah. So I know the whole thing is 1 standard deviation. Yeah. So what I know, and you wouldn't necessarily need to write this because it's probably only worth 1 mark, the probability of being between 64 and 80 is 0.68. So probability of being between 64 and 72 is going to be half that, which is 0.34. Yeah, because I know 0.34 there, 0.34 there. The probability that X is less than 64 given X is less than 7. Oh, geez, I don't like that. I reckon that's meant to be a 70. Probability, look, we're over here, 7's over here somewhere, and the probability of X is less than 0 is undefined at 0. So I reckon that's meant to be a 70, so we'll do it that way. So the probability that X is less than 64 and X is less than 70 over the probability that X is less than 70, that's my conditional law. So to be a number less than 64 and less than 70 means it's got to be a number less than 64 over the probability that X is less than 70. Less than 64 is where? That's there. So if that's 0.34, that has to be 0.16 there. X is less than, it's going to have to be 72, guys, the mean. Okay, so 72 is there, so the chance of being less than 72 is a half. And 0.16 divided by a half is doubling it, or if you like, it's 0.16 times 2 over 1, which is 0.32. All right, so you can't leave your answer as a decimal on a decimal. that you definitely can't do. All right, even if you had to put 16 over 100 divided by 1 over 2, so flip it upside down and multiply, and we can cancel and get 16 on 50. That's fine. That would have been fine even if you hadn't simplified it down. All right, let's try the next one. Question 4. X is normally distributed random variable with a mean 5 and a variance of 9. So mean 5. Now the variance here, I said variance, didn't I? So we haven't seen one of these just yet. Variance of 9. So that means the standard deviation is 3. So the mean is 5, 1 standard deviation, 2 standard deviations, 1 standard deviation, 2 standard deviations. Okay. The probability that X is greater than 5, well, that's just a halfway mark, isn't it? So that's simply a half. Find B such that the probability that X is greater than 7 is the same as Z being less than. Right. So what's the probability? So if X is less than 7, get that as a Z value. The Z value is X minus mu on sigma, which is equal to 2/3. Okay, so that means the probability that X is less than 7 is equal to the probability that X is less than, Z I should say. Let's just rub that out. That's the same, Z is less than 2/3. But, whoops, Mr. Gale. That's what we're saying there, right? However, we need to know the probability that X is greater than 7. So if you like, there's 7 there, right? So if I do another distribution and just make it a 0, 1 distribution, so there's 0, 1, 2, 2/3, which is the Z value, is about there. And I want the probability that X is greater than that, which is that area there, which means the corresponding area less than that is going to be that section there. So what we're going to be saying really, just to really try and spell it out a bit, the probability that Z is greater than 2/3 is exactly the same as the probability that Z is less than negative 2/3. Yeah. So this here, that's the same as the probability that X is greater than 7, which means it's going to be the same as that. So my B value is actually negative 2/3. All right, you might want to just think a little bit there. I may not have explained it particularly well, to be honest, but it really is a case of as soon as you see the Z, we need to go and get our Z value, right, which is 2/3, and then we have to pay attention to our inequality signs, which way they're going, greater than or less than. All right. Number 5, random variable X is binomially distributed with a standard deviation of 1.5. Find the probability of success P. So what do we know about a binomial distribution? We know that the standard deviation is the square root of the variance. The variance is equal to NP1 minus P, yeah? And if the standard deviation is 3 on 2, the variance is equal to 9 on 4. So I know the variance of X will equal 9 times, I feel like I've done this one before, 9 on 4. So my 9s will cancel. So I'm going to get P times 1 minus P is equal to a quarter. Multiply everything by 4. So I'm going to get P minus P squared equals a quarter. Multiply by 4 and take across. So I'm going to get 4P squared minus P plus 1 is equal to 0. So if I use the cross method, oops, it should be a 4 there, I think, should it? I think it should be. Minus 1 minus 1. So I get 2P minus 1 squared, therefore P equals a half. Okay? Hence, find the probability that X is at least 1. So this was from our binomial, wasn't it? Probability that X is greater than 1 is 1 minus the probability that X is equal to 0, which is 1 minus. X is equal to 0, so we had 9 trials, so it's 9C0, 0 successes, times 9 failures, which is equal to 1 minus 1/2 to the power of a ninth. Okay, and in a tech-free scenario, we're certainly going to leave it like that, and we're going to highlight our answers. All right. Question 6. Just make it a bit bigger. Weights of chocolates, bars normally distributed mean 51 and a standard deviation of 4. Mean of 51, standard deviation of 4. Okay. Let Z be the standard normal random variable given that the probability of Z less than 0.25 is equal to 6. So again, because we've been given this information, I'm suggesting we're tech-free. Right. So find the probability that a random selected chocolate bar has a weight of less than 50 grams. Less than 50 grams. So let's find the Z value is equal to X minus U on sigma, which is equal to negative 1/4. So probability that X is less than 50 is equal to the probability that Z is less than negative 1/4. Okay, so if we compare our standard normal curve, there's 0, 0.25 might be there, and we're saying all that area below is 0.6, so that's 0.4. So there's negative 0.25. So this area here is the same as this area here. So that's simply going to be equal to 0.4. Find the probability the random select chocolate bar has a weight of between 51 and 52. All right. So what does that mean? The probability that 51 is less than X, which is less than 52, is the same as the probability. Let's get the Z values. So 51 is the mean. 52 is that one standard deviation above, isn't it? So I could check that. So Z is equal to 52 minus 51 over, not one standard deviation above, over 4, which is equal to 1/4. So it's between 0 and 0.25. So we've already discussed about how up to positive 0.25, I'll do another sketch here. Up to that 0.25, the whole thing was 0.6. And I know to 0 there, well, less than that is 0.5, so that section there is 0.1. So equal to 0.1. All right, so it's just working. As soon as you see sort of this thing here, that should be the prompt to say, okay, I've got to get a corresponding Z values. Couple to go. Wait, wrong one. We're still going. I can check where 50 is. A weight of less than 50 grams is 0.4. Oh, Lily is now eating chocolate bars. One night, Lily eats 3 chocolate bars. Find the probability that at least one of the chocolate bars has a weight of more than 50 grams. So we spoke about that previously. 3 chocolate bars. So all of a sudden, I've got 3 trials. So what's the probability of a bar being more than 50 grams? So since the probability of X being less than 50 is equal to 0.4, probability that X is greater than 50 has to equal to 0.6. And since we're going tech-free, I'm going to write that as 6 over 10, which is 3 on 5. Find the probability that at least 1. So the probability that X is greater than or equal to 1 is equal to 1 minus the probability that X is equal to 0, which is equal to 1 minus, well, 3 trials, 0 successes. Probability of success, we said, was 3/5. Probability of failure, therefore, is 2/5, and that's to the power of 3. So that means that's equal to 1 minus 2 cubed, which is 8, over 5 cubed, which is 125. And you really do need to simplify that. 125 over 125 minus 8 over 125, which is 117 over 125. Okay, let's finish off that question. Question 7. Random variable X is normally distributed with mean 16, standard deviation 4. Normally distributed with mean 16, standard deviation of 4. And Z has a standard normal distribution. Find the value of A such the probability that X is greater than 22, which is here. So I think straight away, hopefully, that's 4 plus 4, that's halfway. So I reckon it's going to be 1.5 is equal to the probability that X is less than A. So I've got to find an equivalent spot back here. So just to sort of, which is going to be sort of halfway between, isn't it? So I'm thinking 10 should be our answer. But just to do that using our Z values, so if X is equal to 22, the corresponding Z value will be 22 minus 16 on 4, which is 6 on 4, which is equal to 3 on 2. Okay, so the probability that Z is greater than 3 on 2 is equal to the probability that Z is less than negative 3 on 2 by symmetry. All right. So now if I want to work out the X value that gives me, negative 3 on 2 is equal to X minus mu on sigma. Multiply the 4 across, I get negative 12 on 2 equals x minus 16. Negative 6 plus 16. Yeah, so that's my formal approach. And my immediate reaction was 1.5 standard deviations above, so it's going to be 1.5 standard deviations below. Righto, part B. Find the value of B such that the probability that x is less than 7, which is even smaller again, is equal to the probability that z is greater than b. So I've got this really small probability here. So my corresponding probability for z is going to be, if that's my z curve, it's up here somewhere, so it's going to be above 2, isn't it? So again, z is equal to x minus mu on sigma, which is equal to negative 9 on 4. So the probability that z is less than negative 9 on 4 is equal to the probability that z is greater than positive 9 on 4, which is what we're looking for there. Therefore, B equals 9 on 4. Let's highlight that answer. All right. Getting there, getting there. Only one page to go after this. Okay, straight away, I think that's 0. Oops. I think that's got to be 0.16. X is the random variable with mean 7, standard deviation of 2. 7, 9, 11, 5, 3. ZB a random variable with the standard normal distribution. Probability Z is less than negative 1 is 0.16. Find the probability that X is greater than 9. All right, so that's what we can see. Hopefully you can see straight away. 9 is there, which is 1 standard deviation above. But if we just make sure Z value is equal to X minus mu on sigma, which is equal to 2 on 2, which is equal to 1. So therefore, the probability that x is greater than 9 is equal to the probability that z is greater than 1. So if on my z distribution, 0, negative 1, that's 0.16. Greater than 1 is also 0.16. 0.16. Find the probability that x is less, given that x is less than 9. So probability that x is less than 7. Better write that properly. X is less than 7 given x is less than 9 is equal to the probability that x is less than 7 and x is less than 9 over probability that x is less than 9. So what numbers are less than 7 and less than 9? Well, it's just those numbers that are less than 7 over x is less than 9. So if we check our table, the probability of less than 7, well, that's just a half, isn't it? And we just said the probability that x is less than 9. Well, if 0.16 is greater than 9, 0.84 is less than 9. So let's turn that into 0.50 over 0.84, which you can never leave as a decimal on a decimal. That's just the same as 50 on 84. And you could probably get away with that, but I would prefer 25 on 42. All right, just half both of them, cancel out by a factor of 2. All right. Question 9, last question. Last question is always good. X be a random variable with a normal distribution mean 20 standard deviation. Mean 20 standard deviation. 10. B can enter into a standard normal distribution. Z's my standard normal. Find the probability. Geez, they're similar questions, aren't they? That x is greater than 20 is the same as the probability that z is less than m. So straight away, enough mucking about. 20 is my halfway mark. So I need the probability that z less than m is equal to a half. And I know that for z, that's got to be equal to 0. M is equal to 0. Bang, straight away. Find the probability that x is less than 18 is the same as z is greater than m. So x is less than 18 is in here. So it's not quite. So let's find a corresponding z value. We know it's going to be negative because it's below the mean. Z is equal to 18 minus 20 over 5, which is equal to negative 2/5. So the probability that x is less than 18 is equal to the probability that z is less than negative 2/5, which is the same as the probability that z is greater than positive 2/5, which is what I'm looking for. It's my z value there. So therefore, n is equal to positive 2/5. Job done. Let's go.